Now we're subtracting in base 9. My max digit in base 9 is an 8. And when I borrow, I'm borrowing 9. You know how when you borrow, let me come up with a little 54 minus 17. When you borrow in base 10, when you make that a 4, you make this a 14 because you just borrowed 1 from the higher place value. You're borrowing 10 of that place value. And so here, when I realize, oh, I can't subtract this 8 from 1 without getting a negative number, but using this traditional algorithm, we wouldn't do that. We would instead borrow. So I make this a 3, but in base 9, I didn't just borrow 10, I borrowed 9. So I borrowed 9 plus this 1 is 10. 10 minus 8 is 2. I can't subtract 7 from the 3, so I need to borrow from this 3, making it 2, and then I need to remember, I bet it's about to get really tricky, I need to remember that I just borrowed 9. Yeah, I borrowed 9. See, I want to make this, the 9 that I borrowed plus this 3 is 12. But now I'm realizing if I was working in base 9, it wouldn't look like that, would it? It would look like this. It's actually pretty interesting, you know? Look, allow me to go back a minute because I just realized something. It's hard to think in a different base number system. When I am trying to subtract this 8 from this 1, and I borrow a 9, the 9 and this 1 are 10 ones, but 10 ones would be represented this way in base 9. It would be a 9 and 1, 1 9 and 1 1. So you do the same kind of thing you do with base 10, but for a different reason. It doesn't represent 10 and 1, it represents 9 and 1. But then when you subtract 8 from 10, you get 2. You still get 2. You want to think this is 11 minus 8 is 3, but remember this isn't 11. This is a 9 and a 1. It's 10. So 10 minus 8 is 2. Okay, when I borrow from this 3, it becomes 2. And this, I am going to write 13 here, but it's not 13 in base 10. It's 13 in base 9. It's 9 and 3. It's 12. 9 and 3 is 12. See? Oh, yeah. For a minute, I thought I made a mistake, but I forgot I borrowed from the 4, so that should be 1 less. Ah, okay. So if that was 3, and I add 9 to 3, I get 12. This is 12 in base 9. Okay, and if I have 12 minus 7, I get 5. Now, 2 minus 2 is 0. Thank you. No borrowing needed. 8 minus 5 is 3. No borrowing needed. All right, now I'm going to check my work, but you're welcome to move on if I feel the need to do it the hard way, because all that borrowing felt very weird. 8341 in base 9 is what in base 10? It's 1 and 4 9s. 36 and 1 is 37. And this is 381s. And this is 8 729s. Well, maybe I'm not going to check it. I know a better way to check it. We can add our difference to our subtrahend and see if we get our minuend. Beautiful. 5278 plus 3052. Of course, both in base 9. 8 and 2 is 10, but that's 1, 1, and 1, 9. 7 and 1 is 8, and 5 is 13, which is 4 and 9, and that's a 3, and that's 8. 8, 3, 4, 1. Yep, good, good. All right. Okay.